Hi guys, for today's video, I'm gonna show some introduction to aviation with principles of flight. First, I'm gonna start with history of flight. First, you may curious about this photo, but this is Leonardo da Vinci. During the 1500s, he filled pages of his notebooks with sketches of proposed flying machines. But most of his ideas were flawed because he clung to the idea of bird-like wings. Joseph and Etienne Montgolfier. In 1783, the first manned hot air balloon flew for 23 minutes. Next is Professor Jacques Charles. 10 days later, after the first manned hot air balloon, he flew the first gas balloon. Sir George Kite, one of the men who believed the study of kites unlocked the secrets of wing flight. Kelly spent his 84 years seeking to develop a heavier non-air vehicle supported by a kite wing shape. He is also the father of aerial navigation. Kelly discovered the basic principles of which the modern science of aeronautics is founded, built what is recognized as the first successful flying model, and tested the first full-size man-carrying aircraft. William Samuel Henson. He designed a huge monoplane that was propelled by a steam engine housed inside the fuselage. Otto Lilienthal, who proved human flight in aircraft heavier than air was practical, worked toward the dream of powered flight. Wilbur and Orville Wright, bicycle building Wright brothers of Dayton, Ohio, experimented for 4 years with kites, their own homemade wind tunnel and different engines to power their biplane. Their biplane, which is the Flyer, combined inspired design and engineering with superior craftsmanship. By the afternoon of December 17, 1902, in City Hall, North California, the Wright brothers had flown a total of 98 seconds on 4 flights. Okay guys, let's go to the next part of this video. Lift and basic aerodynamics. 4 forces act upon an aircraft in relation to the straight and level, unaccelerated flight. These forces are thrust, lift, weight, and drag. Thrust. Thrust is the forward force produced by the power plant or the propeller. Drag. Drag is the rearward retarding force and is caused by disruption of airflow by the wing, fuselage, and other retarding objects. Weight. Weight is the combined load of the airplane itself, the crew, the fuel, and cargo or baggage. Weight pulls the airplane downward because of the force of gravity. Lift. Lift opposes the downward force of weight and is produced by the dynamic effect of the air acting on the wing. The longitudinal or roll axis extends through the aircraft from nose to tail, while the plane passing through the CG. The lateral or pitch axis extends across the aircraft on the line through the wing tips, again passing through the CG. The vertical or yaw axis passes through the aircraft vertically, intersecting the CG. CG is the center of gravity. Well, you might curious about CG, what I'm talking about. CG is the gravity. The CG of the body is the theoretical point at which the entire weight of the body is assumed to be concentrated. The point at which aircraft will balance. It is what the aircraft moves around. The position of the CG or the center of gravity of the aircraft determines the stability of aircraft in flight. As the center of gravity moves rearward or towards tail, the aircraft becomes more and more dynamically unstable. CG is the underline or the green part of the picture. Alright guys, we've done about the lift and basic aerodynamics. Now we go to the next part. The major components of an aircraft. Fuselage. Fuselage is the central body of the airplane and is designed to accommodate the crew, passengers, and cargo. It also provides the structural connection of the wings and tail assembly. Wings. The wings are airfoils attached to each side of the fuselage and are main lifting surface that support the airplane in flight. There are numerous wing designs, sizes, and shapes used by the various manufacturers. Each fulfills a certain need with respect to the expected performance for the particular airplane. The principal structural parts of the wings are spars, ribs, and stringer. Ribs. Wing ribs determine the shape and thickness of the wing. Spar carries flight loads and the weight of the wings while on the ground. Stringers run spanwise and attach between the rib. Their purpose is to serve as structural components that transfers loads and stress. Empennage. The empennage includes the entire tail group and consists of fixed surfaces such as vertical stabilizer and the horizontal stabilizer. The movable surfaces include rudder, the elevator, and one more, trim tabs. Rudder attached to the back of the vertical stabilizer. During flight, it is used to move the airplane nose left and right. Elevator. Elevator attached to the back of the horizontal stabilizer and is used to move the nose of the airplane up and down during flight. Trim tabs. Small movable portion of the trailing edge of the control surface. These movable trim tabs, which are controlled from flight deck, reduce control pressures. Trim tabs may be installed on the ailerons, the rudder, and or the elevator. The landing gear. Landing gear is the partial support of the airplane when parked, taxiing, taking off, or landing. The most common type of landing gear consists of wheels, but airplanes can also be equipped with floats for water operations or skis for landing in snow. Power plant. Power plant usually includes both the engine and the propeller. The primary function of the engine is to provide the power to turn the propeller. Okay guys, let's go on the types of aircraft construction. Truss structure. The main drawback of truss structure is its lack of streamlined shape. In this construction method, length of tubing called longerons are welded in place to form a well-braced framework. Vertical and horizontal struts are welded to the longerons and give the structure a square or rectangular shape when viewed from the end. Additional struts are needed to resist stress that came from any direction. Monocoque. Monocoque construction uses a strength skin to support almost all loads. Although very strong, monocoque construction is not highly tolerant to the deformation of surface. Because most twisting and bending stresses are carried by the external skin rather than by an open framework, the need for internal bracing was eliminated for reduced, saving weight and maximizing space. Semi-monocoque. Semi-monocoque construction uses a substructure to which the airplane skin is attached. The substructure, which consists of bulkheads and or formers of various sizes, stringers, reinforces the skin by taking some of bending stresses from the fuselage. Now we are going to the last part of this video, which is principles of flight. Structure of the atmosphere. The atmosphere is composed of 78% nitrogen, 21% of oxygen, and 1% of gases, such as argon or helium. Some of these elements are heavier than others. The heavier elements such as oxygen settle on the surface of the earth, while the higher element or the lighter element are lifted up to the region of higher altitude. Since atmospheric pressure at any altitude is due to the weight of air above it, pressure decreases with increased altitude. Atmospheric pressure is often measured by a mercury barometer. The density of air has significant effects on the aircraft's performance because as air becomes less dense, it reduces power because the engine takes in less air. Thrust because a propeller is less efficient in thin air. Lift because thin air exerts less force in the airfoils. Oil design. There are four parts of this. It's a chord line, main chamber line, leading edge, trailing edge. Chord line. Straight line connecting the leading and trailing edge of an airfoil. It is the line joining the end point of the main chamber lines. Main chamber line. Locus of all points equidistant from top and bottom of airfoil. Leading edge, the most forward points of the main chamber line. Trailing edge, the most rearward point of the main chamber line. Airfoil design. As the airstream strikes the relatively flat lower surface of the wing when inclined at a small angle to its direction of motion, there is force to rebound downward, causing an upward reaction in positive fluid. At the same time, the airstream striking the upper curved section of the leading edge is deflected upward. An airfoil is shaped to cause an action on the air and forces air downward, which provides an equal reaction from the air, forcing the airfoil upward. If all the lift part were changed merely from the direction of air to the lower surface of the wing, the aircraft would remain flat wing-like kite. However, the balance of the lift needed to support the aircraft comes from the flow of the air above the wing. That's all for this video. I hope you've learned a lot and thank you for watching.